part of the reason I picked this is because we have a ridiculous number of M's and S's, right? So we need to kind of differentiate them. So I'm going to use the bar over the M to show that it's a little m, just for clarity. Does that make sense? What does little m mean? Molality. And what's the definition of molality? Moles of solute over kilograms of solvent. You okay with that? And I just, for the sake of my argument, I'm going to do that as notation. Now, one of the things I do, just because it gets so confusing, this is a Davis thing. I'm going to let A stand for solute, B stand for solvent, and C stand for solution, just so I don't have to keep writing S's that get confusing. Does that make sense? So I'm going to write molality as moles of solute, N sub A, because N is our moles, right? Over kilograms of solvent. And I'm going to call that mass, that's just another little m, of C. Does that make sense? And notice mass of our solvent in this equation is in kilograms, right?
You're seeing the solution, right?
Yes.
Like you're viewing the solvent. So you have kilograms of solvent.
Thank you. Yes, thank you. Solvent. Does that make sense? Now, somewhere here I'm going to have to convert units. So right now, little m sub b is in kilograms. So if I wanted, I could do this. How would I convert that into grams? There's 1,000 grams per kilogram, right? Times mass of B. So this is the mass in kilograms, and that gives me the mass of the solvent in grams. Does that make sense? Not the only way to do this, there's a bunch of ways. That's molality. Big M stands for what?
Molarity.
Molarity is what words?
Moles of solute over liters of solute.
Solution. So using my little notation I'm doing here, molarity, big M, is moles of A divided by the volume of the solution, which is volume of C. And again, if I'm trying to get to grams per milliliter, there are 1,000 milliliters in 1 liter, multiplied times the volume of C. That's going to give me now a milliliter. Does that make sense? Good or bad? Actually, let me write this differently because it's going to get in the way of it. So this was volume of C, and this was, where do I write it? Mass of B, and I'll convert them in a minute because it'll be easier. And you're given, I'm going to put dots, you're given that, right? You're given it on both sides. What do we need to get density? Mass of what? Volume of what? Mass of the solution divided by volume of the solution, right? Does that make sense? So notice here I can do this. If I put this together, so I notice the moles of A is equal to the molality times the mass of solvent. That's in kilograms right now. Do that in a minute. See how I solve this for moles? Does that make sense? Yes. Well, it's one of the subscripts. We're going to have things where there's 8, 9 different pieces of letter. This one, they have that actually. That's things of subscripts. So we have capital M, little m, we have Greek M's.
What?
We have letters.
Great.
But that's why it's so important to identify them. But does that make sense? Oh, you can change the letters in your drawing if you wanted, just like I kind of did here. You could have changed it to other things. So this was moles of A equals molality times the mass of solvent in kilograms. What if I solve this for moles of A? What do I get?
You get the molarity
I get the molarity
times the volume.
times the volume of the solution, and that's in liters, right? So those are now equal to each other. So this equals this. Is that good or bad? What can I do with that now? the only numbers I know here right now are that and that.
Can you plug in a number for the volume?
Again, we're gonna do it symbolically. You can plug in a number, but it's not gonna help us with anything. It's gonna hide the units. So what are you thinking? How would I go about getting, so here you're given the molality, given the molarity, right? How would I go about getting the mass of solvent? What could I do with that?
And the volume of the solution.
Let me backtrack for a second, see if this helps. And again, I'm trying to walk you through logically. So if I were doing this problem numerically, I'm gonna say this is 23.2 molal. I'll start with that one, okay? If you were just trying to start with this, what would you probably do to the first step with numbers?
Put that over in kilogram, just to see.
Be more specific. Where did the kilogram come from?
Same,
Where did the kilogram come from?
from the definition of the.
So I would assume 1 kilogram of water. Does that make sense? And if I did that, this is numerically, I would get 23.2 moles of perchloric acid. What's the formula for perchloric acid? Because that terrifies me as I walk around. HClO4. We have to know nomenclature. You have to know your memory sheet. That's intro Chem. I have 23 moles of that in 1 kilogram of water, right? Well, what I could do here if I wanted is I could say, okay, 1 mole of HClO4 weighs some number of grams of HClO4, and I'd get that number from the periodic table, right? What's that number called? The molar mass. Does that make sense? And when I did that, this would give me grams of HClO4. And here,
That's kind of what we were trying to get.
I now know grams of water. Make sense? Good or bad?
Wait,
Talk to me.
no, I just got confused where you got the grams of water, but I get it.
This was 100. We don't really need the number. I'm just putting here for sake. So this was 2,240.225 grams. This is 1,000 grams of water. So what's my solution weigh? 3,240.225 grams of solution. Does that make any sense as far as that goes? So with numbers, what can I do with that now? Try to get over the molarity. What's that? How? Yes, but I'm doing numbers, graphs are right. She's looking at this and saying, oh, now I know this, that, and that, right? So we can solve it. But over here, pretend that's not there because, you know, I might not have done it symbolically possible. What if I say, okay, I have a solution here that is 11.6 molar. That means what?
Moles per liter.
I have 11.6 moles of HClO4 for every 1 liter of solution. Does that make sense?
Mm-hmm. Yes.
And this other solution over here had how many? The 23.2 molal had how many moles in it?
23.
Had 23.4 moles, right? But we don't know how many liters that was in, do we?
Wait, how do you get
23.2. 23.2 moles of HClO4, and yet we don't know what volume that's in, do we? But you can solve it, it's a ratio. These are the same solution, right?
Yeah.
There's different ways of identifying them. And the volume will be more for that because it's In this case, it's almost exactly double, just purely an accident, but I like it. That's just exactly double. Does that make sense? So what would the volume of the solution be here?
2 liters.
2 liters. So I have 22 moles of HClO4 in 1 kilogram of water, right here, 23.2 moles of HClO4 that contains 1,000 grams of water, and the solution has a volume of 2,000 milliliters of solution. And what's the mass of the whole solution? 3,240.225 grams of solution. And how would you get the density? Oh my gosh, how would you get the density now? Mass of the solution divided by the volume of the solution. The 3,240 divided by the 2,000, and you're going to get 1.665 grams per milliliter. Does that make sense? We can do the same thing here symbolically. So over there, how did I get the mass of the water?
You divided by 1 ml.
1 kilogram.
Assuming each other bigger, they have to assume their work out the other one cancels out. So, coming back to here, the mass of the solvent, right, was equal to that divided by this. Make sense? And N sub A was equal to that times that. You can put those together. Is that enough to get you started, or make sense? I'll show you the final look at the time I'm going to move off this. But again, this is just the logic of walking through definitions, and that's what I'm trying to get you to do. You don't need to memorize this formula. The density of solution, if you continue this out, is molarity times the molar mass of the solid, which was at 100, divided by 1,000, and that's in grams per kilogram, plus 1 divided by the molality. And that gives you the density from straight formulas. One of the things I've done in the past is I gave a class a bonus question where I gave them each of the units of concentration, I told them, and they had to build formulas from one to the other symbolically. So this is just one of those. What gets us so much trouble on this? That's the $1 million question. I think I know those. Huh? Symbols and knowing what the letters mean and keeping it straight. Very often, if we don't know what little n meant in the first place, we certainly have to keep track of all this, right? Have to be able to do that. Again, several of the problems in the homework requires you do that, and people did great on it. Kind of worries me. Well, it doesn't worry me. It just flags me that I know what happens in the distant future when you take an exam. Speaking of which, when is that? Next day is 22 and a half hours from now. All right, let's talk about the quiz here for a second. Quiz question, I changed ammonia to ethanol and instead of giving you 5 data points, gave you 2 for simplicity. Other than that, it's worth a homework problem. And several people did start this one correct.